Hi, welcome back class. We are going to continue with optimization problem. We are solving application problem using derivatives. Alright, in this tutorial question, a rectangular plot farmland will be bounded on one side by a river and on the other three sides by a single-strand electric fence. With 800 meters of wire at your disposal, what is the largest area you can enclose and what is the dimension of the area? Alright, we know that it is a rectangular plot farmland and one side of it will be a river and on the other three sides by a fence. Right, so we know the length of the fence or the wire is 800 meters. So what largest area? Alright, so first of all we need a diagram, right? A diagram of the farmland. Right, one side is bounded by a river, so let's have a river there. Alright, so this would be our river and this is the farm. Right, one side of it will be X. Since this is X, this is going to be X because it is a rectangular. This is also X, and here we cannot have another X, so let's denote as Y. Alright, so question asks what is the largest area, but we also know that the length of the wire is 800 meters. That length 800 meters is basically our perimeter. Right, so let's denote that as P equals to 800, and this 800 is equals to X plus Y. So you're going to have 2X plus Y. Right, from here we can factor out Y to be our subject. Right, so we're going to minus 2X on both sides. So 800 minus 2X. Alright, so let's go back to the question. Question asks what is the largest area? Right, area of this land, of this farm, right, this is our farm, would be X times Y. Right, but we have already found our Y here, so we are going to substitute this Y inside here. Right, so this will equals to X times 800X minus 2X squared. Right, so now we have function of A in terms of X. Right, next we need to find what makes the largest area. Right, so we need to find the derivative of A. So derivative of A in terms of X, so derivative of 800X will gives you 800 only, minus 2X squared, 2 times 2 will gives you minus 4, and X 2 reduced by 1 gives you 4X. Next, we need to find the critical point. So critical point is achieved when the derivative equals to 0. So the derivative is 800 minus 4X, and this is equals to 0. So you're going to get critical point when X equals to 200. So you're going to get a critical point at X equals to 200. Alright, so at this particular critical point, what would be the shape of the graph? Right, so we need to know whether it gives you the maximum or minimum value of A. Right, so we have dA dx equals to 800 minus 4x. Right, from here we get to know our second derivative of A with respect to x is going to give us derivative of 800 is 0. Derivative of negative 4x is negative 4. Alright. Since the second derivative is less than 0, negative 4, for no matter what is the value of x, the value of the second derivative will still be negative 4, and this is less than 0. For second derivative less than 0, your graph will look like this, and this gives you maximum value. Right, so since it is confirmed at x equals to 100, you're going to get maximum value. So we can substitute x equals 200 into our function of a. A 200 equals to 2 times 200 squared. Right, so gives you 160,000. This gives you 80,000. So your maximum area will be 80,000 centimeter squared. Right, and second question, what is the dimension of the area? Right, means what is our value of y just now? Y is equals to 800 minus 2x. Right, we have already know that x is equals to 200. So we can substitute that inside our function of y. So we get y is equals to 200. 800 minus 400, you're going to get 400. Right, so there you go, our value of x and y.